Assalamu alaikum. Today we are delivering into a critical topic in operations management and production planning, sequencing and jobs through three machines. The primary goal of job sequence is to determine the most efficient order of tasks to minimize total elapsed time or our processing time and maximize the utility of a company's facility. We have a series of jobs in this problem, that means n jobs, that must follow three distinct machines: cutting, sewing, pressing, or machine A, machine B, and machine C in a fixed order. A key constant here is that for any given job, the output of one machine serves as the input for the next machine. This means a job cannot start on machine B until it has finished on machine A, and it cannot start on machine C until it has finished on machine B. So at first we'll try to sequence our items in this sequencing model. So solving this three machine problem directly is complex. So we try to simplify that. To simplify, we aim to convert the three machine problem into a functional two machine problem. So we must convert the three machine problem into two machine problem to make a sequence of job. So before conversion, check the following criteria. So if any one criteria is supported, we may proceed with the conversion. So we cannot proceed without this conversion if at least one of the following technical criteria is met. So condition 1 here, the minimum processing time on machine A is at least as great as the maximum processing time on machine B. That means the minimum processing time on machine A is greater than or equal to the maximum processing time on machine B, and this is the symbolic representation of this discussion. Another condition here, to minimize or minimum processing time on machine C is at least as great as the maximum processing time on machine B. Simply we can say that the minimum processing time on machine C is greater than or equal to the maximum processing time on machine B. If either condition hold, we can mathematically treat the system as a two machine sequence to find the optimal order. So first of all, see that here, this is our problem. We introduce here two fictitious or imaginary machines, that means called machine P and machine Q. So the processing time of machine B is the addition of the processing time of the first machine and the second machine. Again, the processing time of machine Q is the addition of the processing time of second machine and the third machine. So we then use these combined times to establish our optimal sequence. So see that in the table given here, machine P and machine Q, these are the imaginary machine or fictitious machine, and P machine, that here cutting machine and sewing machine, we can add this. So if we add the processing time of cutting and sewing, we can make the processing time of machine P. That means 3 plus 3 is equal to 6, 8 plus 4 is equal to 12, 7 plus 2 is equal to 9, 5 plus 1 is equal to 6, 5 plus 2 is equal to 7. Same as processing time of machine Q is the addition of sewing machine and pressing machine. That means 3 plus 5, it becomes 8, 4 plus 8 is equal to 12, 2 plus 10 is equal to 12, 7 plus 1 is equal to 8, 5 plus 6 is equal to 11. So now we can easily develop sequence of jobs from this table. That means converted 3 machines into 2 machines. Okay. So see that here in our sequence of job table, 4 is the first job, and we can on the left side, we can put on the left side. Why? Because 4 is the minimum processing time. Here see that 4 is the 6 is the minimum processing time among, and it is the minimum processing time of machine P. Same as we placed here job or item 1 in the left side. Why? Because it is the second minimum, or it is the same minimum processing time among them, and it is the minimum processing time of machine P or first machine. Then we can place here job 5. Job 5 in that side. Why? Because job 5, see that here the minimum processing time 7 is the another minimum processing time among them, and it is the minimum processing time of machine P. Then we can place 3. Why? Because the processing time here 9, it is the minimum processing time from among, and it is the minimum processing time of machine P. And finally we can put 2 in our empty space or unfilled space of this table, and here 12 is the processing time of machine P, or saying machine Q. So by this way we can develop sequence of jobs, or we can develop sequence of job by this way. See that here the minimum processing time among these we identify here 6. So see that here 6 also in item 1 and 6 also in item 4. So we can start from item 4, or we can start from item 1. Then we can calculate of minimum processing time.